Hey everyone, so we're going to be going over basic types in Elixir now. We're going to be learning those together. I haven't used this language very much yet, so it's something I'm looking to learn, and we'll learn it together. So types in a language are just basically like the building blocks of the language. So in the previous video we went over how to run an IEX session, so if you haven't checked that out, go check that out. And we're going to start up the interactive Elixir, which is IEX, and we're just going to start running through some of their examples. So if we type 1, we get 1 back. If we do this hexadecimal number, we get back an integer 31. So 0x1f is really the number 31 in hex code. And if we did 0xff, we get 255. So that's kind of neat. We also have floating point numbers, which are numbers with decimals. We have booleans, which can be true or false. We have atoms or symbols, which they're just something that represents something. And we have strings, which are just a string of characters, one after the other. And it looks like Elixir also has lists and tuples. So tuples, tuple, however you pronounce it, they're kind of just a set number of values. So if I have this tuple of 1 and 2, that could represent a point on a graph where the first value in the tuple is the x coordinate and the second value is the y coordinate. We could also do a tuple of my name. So we do tuple, first name, last name tuple, and the kind of meaning or representation is we know what it's supposed to represent, but you use tuples to kind of group things together. Just small sets, usually 2 to 4 items would be good in a tuple. Once you get over that, you'd probably want to start using a list or something else. And I believe Elixir has maps, so you'd probably use a map at that point. But we'll get to that further on. So here's some more basic arithmetic. So with integers, you could do 1 plus 2, 5 times 5, 10 divided by 2. So when we do that 10 divided by 2, we get a float back, which is kind of interesting. So notice that 10 divided by 2 returned a float instead of an integer 5. This is expected. In Elixir, the operator division always returns a float. If you do want to do integer division or get a division remainder, you can invoke the div and rem functions. Okay? So division is also a function. So divide 10, 2, and then you get an integer. And it looks like we can get rid of the parentheses, which is kind of interesting. So in the syntax for this language, the parentheses don't necessarily have to be there on a function call, which is kind of interesting. And then let's do a remainder. 10 divided by 3. There's a remainder of 1, goes in 3 times and has a remainder of 1. Let's see what div gives us. Div 10, 3. Yep, so that just gives us the truncated number. Interesting. So 10 divided by 3 gives you 3, and then the remainder would be 1. So pretty cool. Now here's some binary numbers. So 0b, 010, that should be 10. Yep. Octals, these are base 8 numbers. And then we have hexadecimal, which you've already seen. So floats, they're the numbers with the dots. So if we have 1.0, that's the same as 1.0, and then we have 1.0 e to the negative 10. Oh, typed something wrong. 1.0 e to the negative 10. There we go. So I typed in 10.e, -10. We got a compilation error, and that's because this is not a valid value. And what's pretty cool is our program didn't crash or anything. We created an error, we created something that couldn't compile, but our shell is still running. And on a lot of different programs like this, we would have basically had to restart. So that's kind of keying in to why Elixir is such a cool language, because it recovers from errors really well, and that's one of the main selling points of the language and why you'd want to learn it, is that its handling of errors and how that all works is very well thought out, and it actually operates on this thing called the Erlang VM, which is what kind of powers that high fault tolerant error handling. So those are all weird big words, but they don't let them freak you out. So that's kind of floats, so you can represent scientific notation with them too. Now we have another two functions, round. So round and truncate. So that's kind of like rounding up, and then truncating kind of just takes cuts off the value, and these take a float and return an integer basically. So if we truncate 3.58, we're just cutting off that 0.58 and getting just the integer, which is pretty cool. And that's so identifying functions and documentation. Functions in Elixir are identified by both their name and their arity. So arity is like the number of arguments to a function. The arity of a function describes the number of arguments that a function takes. That's what it just says. From this point on, we will use both the function name and its arity to describe functions throughout the documentation. So that's kind of key. So round one, this means that there's a function with one parameter, identifies a specific version of round, and then there's round two, which identifies a different, in this case non-existent function with the same name but with a different arity. So it sounds like in Elixir you can have a function named the same, but if they take different numbers of arguments, they're kind of a different function all on their own. So let's kind of just scroll through this real quick. So we have booleans, that's just true or false. We have true equals false, that'll be wrong in all cases. And then we have type checking things, so is boolean true? Yes, and is boolean 1, that should be false, and we take any value and get a boolean with that. So booleans, if booleans are used for like all sorts of different stuff, conditional logic, just they're kind of the backbone of what a lot of programming ends up being. So this is actually running a little long, so we'll just go over each of these types real quick. So atoms, they're basically just some sort of symbol that you want to use to represent something. So if we have apple in our system, then apple can be used to represent an apple. And if we have one apple, it should be the same as the other apple. And apple should not be the same as orange. So we get true for apple equals apple, apple equals orange is false. So this is a good way to probably pass around values that we want to make sure are the same in the future. So we also have isAtom, and it looks like true and false are also atoms. That's kind of interesting. So true is really just a symbol that's equal to the true symbol. That's interesting. So is atom false? And we get true. So is atom true should also be true. Interesting. And is Boolean false? Oh, spelt it wrong. There is no is capital Boolean. Oh, and that's is Boolean. Oh, somehow on my keyboard I have, there we go. Is Boolean false? So once again, you can see all of that nice error handling, and it's very clear like what happened, and I could just keep working. We didn't have to restart the session or anything. So we completely crashed this with a compile error, but it just keeps going, which is pretty cool. And what these messages were saying is there is no function what I typed, and as you can see, I just typed all of that incorrectly compared to the example. So it looks like there's also a nil symbol. Let's just type in taco. So taco, that can't be anything, but if we need it to be a symbol, we can have the symbol taco. So there's kind of these built-in symbols, nil, true, and false, which are special reserved symbols for this language. That's pretty cool. Alright, strings. Let's see how much more of this there are. Strings, anonymous functions. Yeah. So let's pick up on strings in the next video, and we'll leave this as this. Alright, see you there.